Welcome to the IT office. In this video, we are going to do a configuration called router on a stick. Basically, it's configure inter-VLAN routing. What do they mean by inter-VLAN routing? Well, let me explain you real quick. So we have two VLANs. We have VLAN 10 here on the left, and we have VLAN 20 on the right. These devices on VLAN 10, they can communicate with each other because they are in the same broadcast domain, same as the devices on the right, which are in the same broadcast domain. But there is a small detail. They cannot communicate from VLAN to VLAN because they are in different broadcast domains, right? So in this configuration, we are going to configure inter-VLAN routing, which allows the router to route traffic between VLANs. So keep in mind, when you need to send traffic from one VLAN or one broadcast domain to another broadcast domain, you need a layer 3 device like this router. So we're going to configure two sub-interfaces in router 1 using a physical interface. We're going to configure one sub-interface to use it as the default gateway for VLAN 10 and another sub-interface to use it as a default gateway for VLAN 20. In that way, the router can use a single interface connected to the switch, and then it's going to use that interface to route between the two VLANs. So let me show you real quick. We're going to start by configuring the VLAN on the switches because I want just to recall our previous lessons, right? So let's configure our port. So first port is interface giga 0, which is a trunk port. This is the port connecting to the router. We can use, I'm going to leave it like this. Then we are going to configure port gigabit 01, which is another trunk to the switch access to. Okay, so in this case, gigabit 00 and gigabit 01 must be trunks because they are the ports connecting to the router. And we're going to send traffic for VLAN 10 and VLAN 20 devices here and here, okay? So these ports are ready. Let's configure now the access port of the same switch. So let's go and configure interface. Let's use the interface range command to select various ports. So 1, 0, and 1, 1. This is switch port mode access. Switch port access. Well, they are in different VLANs, right? So let's configure individually the VLAN. Okay, the VLAN didn't exist, so the switch will create it. For some switch brands, you need to create the VLAN because even if you assign the VLAN, the port to the VLAN won't be created automatically. In Cisco, the VLAN will be created automatically, but in some other brands, it won't. Okay, so keep that in mind. Okay, so let's bring those ports up. Yeah, we didn't enable the port, so let me just go back a little bit. So let's check how the status of the ports are right now. So we have two trunk ports, one connecting to router, one connected to access switch 2. We have one access port in VLAN 10 and one access port in VLAN 20. If we see the VLANs, we have VLAN 10 and 20 and assigned ports. And also if we check the trunk ports, we can also see our ports. By default, this port will allow all the VLANs. That's okay by now. I will teach you how to restrict this in later videos. So let's save this configuration. Let's do it real quick on switch access to. So let's configure interface giga01, switch port trunk encapsulation.1q, switch port mode trunk. Let's go to interface range gigabit 101, switch port mode access. Shoot. I forgot to bring up the other port. Let me do that. Shoot, and then interface giga 10. Switch port access VLAN 10 and interface giga 11, switch port access VLAN 20. So let's take a look. Remember, you have to verify your configs after you have finished. So VLAN 10 and 20 with the assigned ports and trunk interface. Okay, that's okay. And what else are we missing? Oh, they show interface status to see what the status of the ports are. Okay, so it looks good. Let's try pinging. So this device has the IP address. Let's take a look. 10.10, 10.0.11, 10.0.10.11, and PC3 10.0.10.33. So let's ping it. 10.33, yeah, that works. And let's check PC2 10.0.20.22, and here 10.0.20.44. Okay, let's ping 10.0.20.44. That's okay. Okay, so let's test our theory. So let's ping 10.0.20.22. Yeah. So there is no way to ping that because we haven't configured yet the router. Okay, so let's go to the router now. So let's show interface, show IP interface brief. There's no configuration on the router itself. Then we're going to configure that sub-interface. So let's do the following. Interface gigabit 00, no shut. Interface giga 00. So this is going to be the first sub-interface. Encapsulation.1q, and then the VLAN ID. So this is a sub-interface for VLAN 10. So IP address here will be 10.0.10.10.1 with /24 mask. Okay, let's exit. Now interface gigabit 0.0.20 encapsulation.1q. Remember, 802.1q it's a trunking protocol, so it means that this gigabit 00 is going to work as a trunk with two sub-interfaces, gigabit 0/010 and gigabit 0/020. Okay, so address, IP address 10.0.20.1/24. Just in case no shutdown. So let's see the interfaces. Show IP interface brief. Show IP interface brief. So we have now two sub interfaces. We don't need in this configuration we don't need to assign an IP address to the physical interface. We just need the sub interfaces since we are doing tying, right? So let's try to ping PC1 10.0.10.11. Okay, it's responding. Let's try to ping PC3. All right, let's try to ping PC. Let's try to ping PC2. Okay, and let's try to ping PC4. Okay, so let's take a look from here from PC1 to PC2. Now we have routing in place. Okay, so let's see. Let me check. What's the default gateway? Oh, it has by error. I think it has a different gateway. Let me check the configuration. Let's see. Okay, yeah, that's why it shows like a redirection or something. That's weird. Let's double check these other devices. Keep in mind, you need to configure the gateway. The default gateway will be the router. Remember, when you need to send traffic across different domains, broadcast domains, you need a router in the middle to do the routing. You cannot have communication between different broadcast domains without a router or any layer 3 device. So keep that in mind. That's very important. So now let's take a look. Let me reconnect. So let's see route. So the default gateway is 10.0, 10.1. So ping 10.0, 20. Let's ping PC2. Right, now it looks good. Let's do a trace route. I'm going to explain how this protocol works in later videos. If you do a trace route, this command will try to see what are the hops that we need to reach the remote device. So we have to jump to the default gateway or the router in this case, and then we go straight to the device. If we go to PC2 and ping PC1, it should work as well. And if we do a trace route 10.0, 10.11, it will go first to the default gateway 10.0.21, and then we'll reach the device. So that's how Inter-VLAN routing works. Also, very important, you should have an ARP entry for your default gateway. Okay, that's very important. If you're able to have, okay, this one hasn't communicated to anything in the network. Let's ping first the router. It has communication to the router, ping 10.0. Let's try PC2. Yeah, ARP. Yeah, so it has an ARP entry for the default gateway. That's very important because that will allow to complete the layer 2 frame information to reach the default gateway. So remember, here we have two sub-interfaces, 0.10 and 0.20, right, in the same gigabit 00, working as default gateway for each of the VLANs. So when this device, PC1 for example, needs to send traffic to PC2, it will do, for the first time, will do an ARP request. So it will send a broadcast asking for the MAC address of the default gateway. I mean, in the configuration, it has 10.0, 10.1. So it will do an ARP for this device. If you watch the ARP video, you will understand this clearly. So the router will respond that ARP, completing the layer 2 information. So then it will be able to send the packet destined to PC2, right, across its default gateway, and the packet will reach PC2 and then come back in this direction. Okay, so let's do something else, because I always want to show you real world troubleshooting, right? So let's capture packets here in gigabit 00. This is very important because in the real world you're going to deal with packet captures all day and all night. Okay, so let's do a ping to PC2 and let me show you the traffic flow. So it will be PC2. So let's see, ICMP. Let's filter the packet capture. Let me stop it. That's enough. So let's check one request and one reply. Okay, so you will see this packet capture. You will see request replies twice. I will show you why. Let me apply this as a column. This is a VLAN ID. Okay, so as I mentioned before, this traffic leaves PC1, it sends to the router, right? Here we have a trunk port, so it will be tagged with VLAN 10. This is the first request, as you see here. Then the router is going to send that traffic over VLAN 20, the same request. I'm going to tag with VLAN 20 tag, as you see here, is the same request. Then we have the reply from PC2 is tagged with VLAN 20, right? Now this time is the reply, and then the router is going to send that reply, but in this case we're going to use a tag for VLAN 10. The traffic tag will be this traffic which is tagged is sent to the switch. Then the switch will strip off the tag and send it to PC1. So by the time it reach PC1 or PC2, it doesn't have tag. It's tagging just significant over the trunk port. Just keep that in mind. But here you see request VLAN 10, request VLAN 20, then the reverse traffic reply VLAN 10 and VLAN 20. So you will see twice the packets through this port. Okay, so you have in this case we are using a single interface. There are topologies where you can have an interface for VLAN 20 and VLAN 10. That's not that common because that's just a waste of interfaces, but just keep this flow in mind. So traffic leaves the switch, it will be tagged with VLAN 10, then same packet will be tagged with VLAN 20, then the return traffic tagged with VLAN 20, and then the last reply tagged with VLAN 10 before being delivered to PC1 or PC2. So that's how router in stick works. Okay, so I hope you have enjoyed this video. Don't forget to subscribe, like, and turn on the bell to receive notification when we have new videos. Thank you for watching.